Okay, so we're going to talk about the homework lesson in my math lab that's titled Key Graphs, and that's basically all it is. We're just going to have a discussion about some of the key graphs that we see all the time in math. And this is kind of an introductory lesson for the 4.1a lesson, which is on transformations, because we need something to transform, to move around. And these key graphs that we're going to talk about today are going to be the graphs that we're going to work with in that lesson extensively. So consider this kind of an introduction that's going to get us ready for the next lesson that uh, we're going to do. So first off, I'm just going to show you what I'm going to give you a handout. I'll email it to you in the email that I send with this video, and then I'll also have some copies that I bring with me to class on Tuesday. But I would recommend printing these out so you have them available to you when you're doing your homework assignment here. So let me pop over there. Okay, so this is what our key graph handout looks like. There are 7 key graphs, although we don't really use the first one very much in this. So there's really the 6 key graphs here that we're going to be working with quite a bit. Okay, and again, I will attach a copy of this paper to the email that I send out when I send out the a notification about this video being done. Okay. Uh, and so what I'm going to really do here is I'm just going to pop into Desmos. We're going to look at these functions kind of one at a time, and then we'll discuss some of the concepts that have to go with them. Oh, I guess while we have this on the page, I am not going to give you this sheet on your exam. Okay, but what I am going to do is if you forget about the identity, there are 6 of these left. I will 100% on the exam have a list of these 6 equations, okay, probably like labeled A through F, right? And then I'll have these 6 graphs and I'll ask you to match them up. So you don't have to have these memorized, but you have to be familiar enough with this sheet so that you can use that matching section to match them together. And then you can use that problem on your test as kind of a reference chart for the rest of the exam. Okay. Now, the good news is there's a problem that's exactly like this in your homework assignment. So if you want to practice that a few times to make sure you're ready for that problem on the test, that's probably a really good idea. Okay. But let's hop over into Desmos now so we can talk about what these different functions look like, some of the factors that go into them, and all that good stuff. Okay, so we'll start with the f of x equals x. And all this is a line passes through the origin, the y-intercept 0, right? There's no value on the end. And our slope is 1, up 1 over 1. And again, this is more just because we want to kind of concede that lines are important mathematical concepts, but it's not the most interesting thing to shift, stretch, compress, all those good things. And plus, we already know a ton about lines. We're not really going to use the transformation stuff we're going to learn in the next lesson to work with lines. So this is one I'm not going to spend a ton of time on. Again, we know a lot about these linear equations already. This is just the most basic kind of, when we say the key graphs, we're talking about like the most basic form of these graphs that we're going to run into. Okay, so we'll move on from this one and let's go ahead and start to talk about the first key graph that we'll definitely see on this exam. And that is one we've been working with a lot already in this module. That is the x squared graph. Okay, so this is a parabola, right? This is a quadratic equation where my A is 1 and my B and C are 0, right? So no surprise that my y-intercept is at 0, 0, since my C value is 0. Also no surprise that this opens up because my A value is 1, okay? So one thing that we're going to ask you to think about when you're doing these homework assignments is domain and range for some of these key graphs and their intervals. Okay, so let's talk about domain and range for this particular graph. So if we're doing domain, remember we're thinking about the x values, right? And we're working our way across the graph from left to right. Okay, so if I'm going to do that, uh, then the first thing that jumps out at me here is there is no leftmost point on this graph. It just keeps going and it goes to the left forever. So when that happened, we said our domain started at negative infinity. Let me see if I can get an infinity here. And uh, yeah, maybe I'll have to do this on paper. I do not see an infinity on here. Okay, well, so it's from negative infinity to infinity. Let's call it, we'll just do an I. Remember, we're going to use that infinity symbol. So negative infinity because we go to the left forever, and then positive infinity because we go to the right forever. That's our domain, right? Then our range, remember we're doing bottom to top, thinking about the y values. So our bottommost y value is at 0. 0 is included, so we're going to use a bracket on that. And then we're going to go up forever to positive infinity. And again, when you're doing this in MyMathLab, make sure you're using uh, the infinity symbol instead. It tries to finish that out. It's not necessary. You just want to bracket in front of the 0 because 0 is an actual point on our graph, and an I on the infinity. Let me just do it on the paper. Sorry, it's a little bit of a mess here. So for x squared, graph looked like this. Domain was left forever to right forever. And range was bottom, which is at 0, which we include because it's a real point on our graph, to infinity since it goes up forever. Okay, so there's our kind of facts for the x squared curve that we want to remember. Okay. All right, so next we're going to move on to our graph x cubed. Okay, so this is called a cubic graph, and we'll deal with cubic polynomials in the next module, so we'll see this a lot more. But for right now, again, we're just looking at the kind of the baseline cubic equation. Okay, and that's going to look kind of like this. It kind of looks like it's a parabola up here, but instead of it turning and becoming the U-shaped graph, what it does instead is it just kind of reflects down here into quadrant 3. Okay, so this is what our baseline x cube graph is going to look like. Okay. Uh, and so let's talk about domain and range for this one. Let me switch back here. So our x cubed graph, cubic graph, looks like this. Okay. And so our domain, we're thinking x values left to right. We go to the left forever. So we would start at negative infinity, go to the right forever. So it goes to positive infinity. Oops, sorry, my pen kind of died here. 1 second. Okay. So there's our domain. Our range, on the other hand, we're thinking about y's and we're doing bottom to top. Well, this one goes down forever, which means it starts at negative infinity, and goes up forever, which means it goes to positive infinity. So basically, with a cubic function, you can put in whatever you want for x and you can get out whatever you want for y. All real numbers are possibilities there. Okay? So there's our second key graph. Okay, the third one is the square root of x. And this one's a little different because it doesn't go to the left forever, right? It just kind of has a starting point where this kicks off. So let's talk about why the graph has to look like this. Okay, so first thing is we need to know, we talked about this a little bit last time. If you try to plug a negative number into this square root function, you just can't do it. Like if I try to do the square root of uh, and to get the square root, by the way, it's just right down here in the template. If I try to do a square root of a negative number, it just doesn't work. We get an undefined function. And that's because we're looking for something that we square to give us the value inside of the radical symbol or the square root symbol. Like the square root of 4 is 2 because 2 squared is equal to 4. Okay, the square root of 9 is 3 because 3 squared is equal to 9. The square root of negative 4 doesn't work because there is nothing in the real numbers that you squared to get a negative 4. So that's why there's nothing to the left of 0 on this graph. You just can't plug negative numbers into a square root equation like this. It just doesn't work. Okay, now one thing that I'm going to kind of add is a little interesting fact about these square root functions. Let me graph that, and let's graph negative square root of x at the same time. And if we do that, we put the square root of x and negative square root of x together, we actually get a parabola that opens sideways. Okay, so this is exactly the same as the graph of x squared, just opening sideways instead of up and down. Okay, uh, So the reason we don't care about this plus or minus square root of x graph is because if we put them together, we get something that's not a function, right? It's actually also the graph of x equals y squared, by the way. But what we really have here is the top half of a parabola that's opening to the right. Okay, so that's what's going on with this one. Okay, let's talk about domain and range. So just pop back over here. Okay, so square root of x, sometimes we call this our radical equation. Okay, our graph looks like this, shoots off to the right. Okay. And so our domain, again, we're thinking about x's from left to right, goes from 0 to infinity. Our range, we're thinking about y's going from bottom to top. So our range, again, starts at this point is 0, 0. So our x starts at 0, so does our y. And then we go up forever to positive infinity. Okay, so that's the square root of x function. Okay, so let's move on to our cube root. Okay, so the cube root is, it kind of looks similar to the square root as we go to the right, but we do have this kind of reflection down here in the third quadrant that mirrors what's happening in our first quadrant here. And so our domain is going to be quite different. Even though these two functions look similar, they're going to be quite different. The reason for that is, like if we do a cube root, and by the way, if you ever want to do a cube root or any radical that has an index that's not 2, you just have to pop in here to the functions menu, go down to the very bottom, and then just choose this option right here. So if I do something like the cube root of 8, for example, the cube root of 8 is equal to 2 because 2 to the third, 2 times 2 times 2 gives us the 8, right? Uh, 64, the cube root of 64 is 4 because 4 times 4 times 4, or 4 cubed, is equal to 64. Okay, so that works very similarly to the square root. The difference, though, is if I put a negative 8 in here, I get negative 2 because negative 2 times negative 2 times negative 2 does give me the negative 8 that I'm looking for. So that's why our domain is different. You can take the cube root of a negative number and it will work just fine. The cube root of negative 64 is negative 4 because negative 4 times negative 4 times negative 4 gives us negative 64. Negative 4 cubed is negative 64. So that's why our domain is different. We can't take the square root of negative numbers. That doesn't work with real numbers, but we can take the cube root of negative numbers and get real numbers out of it. So that's why the domain is so different here. Okay. So let's talk about domain and range for this one. So we'll pop back in over here. Our function looks something like this. So if we're talking about cube root of x, okay, our graph looks kind of like this. Beautiful drawing skills. Domain, we're going to go from left to right across. This one goes to the left forever, so it starts at negative infinity. Work our way to the right forever to positive infinity. Range, on the other hand, goes down forever, so it starts at negative infinity, and then goes up forever, so it goes to positive infinity. So you can put in whatever value you want for x, any real number works, and you can get out whatever number you want for y. Okay, all real numbers for both domain and range on that one. Okay, so we're getting there. Our next one is a very important one, especially for science. We see a ton of these absolute values in physics, in chemistry, uh, very, very common for us to get. And basically, what the absolute value function is, it measures the distance of a number from zero. Okay, so if you put, and if you want to get the absolute value, there's actually a little link for it right down here. Okay, if you put a positive number into the absolute value function, like 3, nothing happens. We just get that same value, right? So the absolute value of 3 is 3. The absolute value of 7 is 7. The absolute value of 100 is 100. So if the absolute value doesn't do anything if you plug a positive number into it, right? But if you plug a negative number into it, like -5, what the absolute value does is it changes its sign. So you're going to, the absolute value of -5 is +5. The absolute value of -12 is +12. And that's all that the absolute value function does. If you put a positive number into it, you can just drop the absolute values off. They don't do anything. If you put a negative into it, it just drops the negative sign and makes it positive. That's why this graph looks like this. And that's why this graph will never go below the x-axis. We can't get negative values out because if you put a negative number in, it reflects it and gives you a positive number out. Last thing to note here is that the absolute value of 0 is 0, right? If the opposite of 0 is still 0, so 0, 0 is this vertex point on our absolute value function. Okay, so we just get a V-shaped graph that looks like this. Those are the reasons why. It's just the graph of y equals x over here. It's just the graph of y equals minus x over here, in fact. Okay, so let's talk about domain and range for this thing. Okay, so if I've got the absolute value of x, we get this V-shaped graph. Sharp point here, no curve at all. In fact, there's no curves in this graph at all. There's no concavity. Just two, we call these rays. They're just like pieces of lines. Okay, our domain here is, well, goes to the left forever and to the right forever, thinking about x's, so -infinity to infinity. And then our range, again, going from bottom to top, it starts at 0, we include 0, and then it goes up forever. So that's what we're looking at on that one. Okay. And then our last one is the most interesting one. It's the one that has the weirdest stuff going on. Okay, so this graph 1 over x, sometimes we call it the reciprocal function or the inverse function. Okay, it looks something like this. Okay, and so I'm going to draw a couple more lines on here. Let's say we have x equals 0, and we have y equals 0. Okay, we're going to kind of need those to talk about. These are not part of the graph. The black vertical line and the red horizontal line, they're not part of the graph of this function, but they do help us draw this graph. Okay, so why does this graph look so weird? Well, there's a problem spot with this particular function. We've talked about it a few times. Actually, way back in section 1.1, we talked about the problems that we can run into sometimes. And the big one that we always have to keep in mind is you cannot put a 0 in the denominator of your function. You can't divide by 0, right? It just doesn't work with the way that we use fractions in math, right? So that's why this graph has this situation. This black line that I've drawn in here is a vertical asymptote that's running up and down along where x is equal to 0. And the graph can never get there. It can never touch this black line because if you did, you'd have to put 0 into this equation, puts a 0 in the denominator of our function, and that is just not allowed with the way that we do fractions. Okay, so that's why this graph has this weird behavior. There's this black vertical line that we've got running along here that this graph is going to get closer and closer to forever, and it's never going to touch it. It just can't. It's not possible for it to touch it because it's just not allowed with the way that we do fractions. And then similarly, this red horizontal line, our graph is going to get closer and closer to it forever, but it's never going to touch it. Okay, and it happens on both sides, right? We're going to approach it, We're going to get closer and closer to it forever, but we just can't touch it. Now, why the horizontal asymptote is at 0, that's a little beyond the scope of this course. You'll have to kind of trust me on that one. There's some concepts that we don't learn in this class in order to explain why that one happens to be at 0, but just trust me that for the graph 1 over x, our horizontal asymptote is going to be running right along the x-axis here. We're going to get closer and closer to that forever. Okay, so an interesting graph, just completely split up into two separate pieces, one of them in quadrant 1 up here, the other one in quadrant 3 down here, and then we have these two lines that are not really part of our graphs, but we can sketch them. Usually when I sketch them, I'll sketch them with dashed lines. That indicates that they're not really part of our graph, but they're helpful to draw because our graph is going to approach them but never touch them. Okay. So that's kind of the most tricky one. So let's talk about domain and range for this one, because again, this is the most tricky of these to understand, I think. Okay, so for our inverse function, our graph is 1 over x. Our graph looks something like this. Okay, we have a vertical asymptote running up and down along the y-axis. We have a horizontal asymptote running across the x-axis. And then our graph is kind of trapped in quadrants 1 and in quadrant 3 by those asymptotes. So it looks like that. Okay, so let's talk through the domain and range. There's definitely more going on here. So if we're going to do the domain, okay, the first thing I note is that this graph goes to the left forever. Okay, so my domain is going to start at negative infinity, and then we're going to go until we kind of get closer and closer to our vertical asymptote, which is at 0, but we never touch it, right? So we're going to put 0 here for the end of our domain, and then we're going to put a parenthesis to indicate that we never reach that point. Okay, then we have a completely separate chunk of our graph. So when I'm doing this, it's going to ask for intervals in your homework. I'm just going to use the U-shaped graph. Or sorry, I'm going to use the U to indicate there's another piece. It's just the math symbol for and. Okay, then we have this other chunk over here. We're going to work our way across from left to right. This one starts at 0 again, but doesn't include 0 since we're approaching but never reaching. And then it goes to the right forever. Okay, we did this in section 1.1 when we did these similar domain problems. Okay, the range is going to work very similarly, except for now we're thinking about y's. We're thinking about bottom to top. This graph goes down forever. We're going to work our way up until we approach that asymptote, but we're never going to get there. Whoops. Now we're going to go to 0. We're not going to include it because we never actually get there. And then we're going to pick up from 0 over here, and then we're going to go up forever to positive infinity. And this is how you'll write the domain and range for this function as an interval. If I was to ever ask you this on the question, I prefer this solution. X can be whatever you want except for 0. Same thing for the range. Y can be whatever you want except it can't be 0. So those are two different ways to say the same thing. MyMathLab is going to want the intervals, so that's why we kind of focused on those. Okay, and so that's our introduction to these key graphs, right? We have these basic key graphs that you're going to want to be familiar with, because in our next lesson, what we're going to be doing is moving these key graphs around, shifting them. Okay, we're going to be stretching them out and compressing them. We're going to be reflecting them over the x-axis. We're going to be manipulating them in different ways. And if we're not familiar with the key graphs, then we won't have a good baseline to start from. So you do want to be familiar with these, but again, this is another very short, very straightforward lesson, as long as you have your sheet handy. And I will attach the sheet to the email that I send with the instructions for accessing this video. Okay. All right, guys, let me know if you have any questions. I'll be back with one more lesson a little later today. Y'all have a good day.